Sure is, yeah. By our standards, it's a little cold, but quite warm this time of year.
Well, it was 70 this morning. I don't know what anybody else got here. So, anyway, thank you for being up so early. Really appreciate it. Kyle Polish is a data scientist with a background in artificial intelligence, holding both a bachelor's and a master's degree in computer science from the University of Illinois at Chicago. He is the host of the Data Skeptic podcast, which focuses on data science, artificial intelligence, machine learning, and statistics. Kyle aims to make complex topics understandable to a broad audience, exploring how data science impacts our everyday lives and the ethical considerations it entails. In his professional career, Kyle has leveraged his expertise across various industries, including space communication. Space communication. I just lost my spot. Oh, digital advertising, finance, and e-commerce. His work involves data analysis, predictive modeling, and the development of algorithms to provide data-driven insights that guide strategic decisions. By applying artificial intelligence and machine learning techniques, Kyle addresses complex challenges, applications of these technologies in solving real-world programs. And here's a photo, but you have him here also, a photo. And and if we were on Star Trek, you could all beam up and down and you wouldn't need a photograph. So thank you. And if I didn't thank you for volunteering, I apologize. Just looking around, I want to make sure I got everybody. Okay, so we're going to begin. And Kyle, I'd like to tell you that we have a member who was trying to get you a flyer that we did, and he's involved in his own home working with AI, and I believe that he's going to have some very specific questions for you later.
Cool. Sounds
Okay,
good.
good. All right. So welcome, Kyle.
Thank you very much, Carol. I'm going to go ahead and share my screen, pull up my slides here. Give me just a second to get that going. Do you guys, oops, not share. Let me hit done. Slideshow is what I wanted. Do you guys now have a screen that says a staircase to the moon, the path to AGI? Is that we good? I think so, yeah. All right, I'll kick off. So I titled my talk "A Staircase to the Moon." It really is an analogy. It's an exciting time to be studying AI. Over the last, couple decades, I've been involved in this because so much has changed and developed for a number of reasons we'll get into. But the goal being AGI, that is artificial general intelligence, a machine that can truly think in the same sense that humans think, it's something we may or may not be on the track of. For example, if we want to build a staircase to the moon, we could probably make a lot of progress along the way. You could, maybe invent new material science to make the stairs stronger or lighter metals that make the staircase higher. But somehow, I just don't believe you're ever going to build a staircase to the moon. That's not the right solution. So we're in a time now of asking the question, is our current approach to AI, even though it's obviously doing a lot of useful things, maybe some unuseful things as well, is it the path towards a truly thinking machine, or is it just some sort of mirage we're in? I don't have the answer for you, but hopefully I'll convince you that we are not building a staircase to the moon, that the current path of AGI is something a little more than that. Oops. As an analogy, think back to the days of Orville and Wilbur Wright when they were building the first airplane. Of course, we know their design and we know the design of planes today. And everyone, you see a plane, you say, of course, that's a plane. But before planes were up and running at the scales we have today, people really didn't know what was the proper design. We had birds to look at. Our planes don't work like birds. And eventually engineers found a model that does work, that is able to provide air travel, not resembling many of these crazy designs, but we're in a similar phase now with AI. We have a lot of designs and approaches, and we're wondering which is the most fruitful one if we're going to try and build a thinking machine. So, in 2018, way back in 2018, this book, The Master Algorithm by Pedro Domingos, came out. I got to interview him about the topic,
Yeah,
and
thank you.
essentially, he has an idea of five tribes, and these are sort of academic approaches to how we'll create AI. And while all of them are still relevant, they all contribute value in different places. The field has really honed down to just one of these. To give you some analogy as to what these are, I won't go through all of them. Let's consider the evolutionaries, as Domingos names them. These are people who think we can achieve AI by kind of taking ideas from evolution. So imagine if you have a problem you're trying to solve, and you can express the solution to the problem as a series of information. So in DNA, that's, these A, G's, C's, and T's in an order. But it could be a finance problem where you're deciding which stocks to buy and sell. Can you start from a bad solution or a pool of bad solutions, find the ones that are less bad, breed them together somehow, combine the good ideas from two things, and then let the most successful solutions survive? So while that is a useful technique, it's not used in a lot of the AI making headlines today. In fact, out of these five tribes, we've really centered on one, what Domingos called the connectionists approach. And you could think of this as ideas that are inspired by the human brain, or, well, any brain really, but it's the human brain that seems to be the most advanced in terms of intelligence, at least as far as we know. But easy for us to say that, right? So the key concept of a connectionist is what's called a deep neural network. I drew a very small one here on the left with the circles and dots that I'll explain to you. Won't get too technical, but as long as you can do arithmetic, you can do all the math on the board. So these circles are what we call nodes. You can think of them as like neurons in your brain. And the arrows are what we call edges, which are a little bit like the dendrites in the brain. Not quite, I'm sure a neurologist would roll their eyes at this analogy, but it's an analogy. So imagine X's are your inputs. Maybe that's from your senses, like your eyes or your nervous system or whatever coming to the brain. And there's some output, which in terms of the brain is your behavior, but or your thinking perhaps. But of course, we can apply AI to other fields. Maybe the input is the pixels of an image, and you want to ask the question, does this image have a horse in it? And then the output is 0 or 1, horse or no horse. Now, to get there mathematically, we have these H nodes we call hidden nodes. And here's some very simple math. It's take X and multiply by W, where there's a weight attached to each of these arrows. So that's just some value that says the strength of that information or that connection. So do some arithmetic, get a couple of H's, take an average of those three H's, and that's your output. So there's the very simplest neural network. Well, technically you could have a simpler one, but a fairly simple neural network. Definitely not intelligent. No one would think that these 6 nodes represent anything like intelligence. Pictured here, we have the 3 layers, the input layer of X's, the hidden layer of H's, and the output layer of O's. And we have 6 parameters. That's these weights on each arrow. So if you wanted to optimize this, to find a good solution to a problem, you would have to find the best 6 values to make the math work out. So that's the key concept. And if I ask some of you who are better at math, maybe how could we, given 2 values of x1 and x2, how can you get the output you want? You could probably back into it. But now take that same idea and scale it up. Instead of 3 layers like I drew, try and picture 96 layers, which wouldn't fit on my screen here very well. And then instead of 6 weights, these W's here, imagine 175 billion weights. Also not easy to picture on one screen. That's GPT-4, the popular language model you might talk to if you go to ChatGPT, or if you go to Grok or Bard or any of these others. They're all more or less taking the same approach. Some have this advantage or that advantage, but they're this very simple idea just scaled up massively from 3 layers to 96 or more in some cases, and from 6 parameters to billions and billions of parameters. So the large language model, these things like, and I'll use that term LLM as the general category for things like ChatGPT. As I hope you know, hopefully you've tried them. If you haven't, now's a good time to pull out your phone and go to one of them. They take a text input. They have that same methodology, that mechanism inside of nodes and edges and weights, and they output some predicted next word. So for whatever text you give them, it's going to try and guess what the next word is and what word comes after that. And I'll get a little bit more into how it does that. Although the short answer is it's just this concept on the previous slide scaled up. Now, if you want to use these tools, someone obviously at OpenAI and these various places have built them, but they've provided them in a way that's accessible. So even if you're not a programmer, this program that fits on one slide is what, maybe 15 lines of code. You could copy and paste this into your own Python system. And well, you need an open API key, but they give those away for free, I think. And you could utilize that model via the internet. With this code, you would call out from your home computer to their computer. You'd give it some text, what I call the prompt here, and they would continue that sentence. So if I said something like the climate of Mars is, it would continue that sentence and say, not very good this time of year or something along those lines. So it's not a technology that's been put into an ivory tower that is inaccessible. It would be difficult, if not impossible, for me to train my own model, but the models that are out there I can use, sometimes via an API like this, or if I want to download one. So why did this happen now? It was back in the 1950s when the first conference on artificial intelligence was organized and serious academics started talking about the topic. And they thought, hey, maybe we'll have this thing wrapped up in about 10 years. And here we are several decades later. Why now is there an AI explosion? And really, there's three key reasons. The first is the GPU, or graphics processing unit, as you see on the left here. It's very poorly named in a certain sense because we're not talking at all about graphics. Those that computer hardware was developed primarily for people doing games. These 3D games require a lot of algebra and computation to know, when you turn your character to the left, how does the screen shift? And so, of course, these GPUs were designed for that purpose. But what was discovered was that same linear algebra that goes on in that graphics card, massively parallel computation, is incredibly useful for AI and the types of machine learning techniques that have given rise to the advancements we've seen today. The brain is exceptionally parallel, and the GPU is exceptionally parallel, and they have that thing in common. Now, the second big advancement is what I call big data, or maybe you just want to think of the internet in general in a way that certainly wasn't true in the 50s. Today, there's a massive amount of digitized information. So I can take maybe the whole corpus of Wikipedia and all of the works of Shakespeare, or maybe all of the works of any author that we still have since, the earliest days up until 1910. And you could probably fit that on your home computer and download that from somewhere. So the availability of data upon which you can train AI is massive. And third, and certainly not least of this list, I call algorithms, or specifically the transformer architecture. I'll talk a little bit more about what that is, but that's sort of the secret sauce, the key algorithmic or mathematical trick that has made a lot of this possible. I want to draw a couple of quick analogies to, if we're on the path to AI, can we say when computers have gotten as big as the brain, or these models are as big as the brain? I assumed in my, sort of human arrogant way that we had the biggest brains on the planet Earth. We do not. Elephants have more brain size, at least when measured in neurons. It's actually a log scale. If you notice my axis here, the real data is in the upper left here, but it's so striking. The elephant is more than double the human in terms of neurons, and it makes it hard to see some of these other things I included. So log scale, just like the Richter scale, from frogs all the way up to humans and then elephants, we need 10 to the almost 10 to the 11 neurons in the human brain. Now, it's not a fair, direct one-to-one, apples-to-apples comparison, but if we look at some of the popular language models over the last couple of years and we consider the number of parameters. That's those W's I had on my slide earlier, where in my example there were six, but there are billions and billions. Already, the amount of parameters used in these systems are greater than the number of neurons in the human brain and even the elephant brain, at least when we compare them to GPT-4. So this tells us it's not exactly the right scale or the right measurement tool to be using. Simply the number of parameters is important. GPT-4 is much better than GPT-3, which is better than 2 and 1 and so on. We know that from interacting with them and testing them. So more parameters is better, but the systems today have more parameters than we have neurons. So clearly that's not sufficient. It's necessary, but not sufficient. So how do we measure AI, or specifically AGI, artificial general intelligence? AI in many senses has become a marketing term. It's something a company says they have in their product to get attention, to put out a press release, this sort of thing. Like any good product, the proof is in the pudding. Does the product do what it claims to do? It's less important how you made it. But when it comes to the question of have we produced an intelligent machine, how do we scientifically answer that question? And the answer's been known for several decades, going back to the founder of the field of computer science, in some sense, Alan Turing. One of his many contributions, you've probably heard of the Turing test, or as I prefer to call it, the imitation game. You may have also heard in the news that the Turing test has been passed. This is demonstrably false and bad reporting. The Turing test has not been passed. So, what do most people probably know about the Turing test? That you sit in front of a computer, maybe you know that you talk to a human and you talk to an AI, and if you can't tell the difference, then that machine is assumed to have AI. More specifically, you're playing a game. It's the imitation game. You know that you're talking to, you have two computers in front of you. You know one, and there's two chat windows in it, or, a chat window in each computer. Behind one of those chat windows is a human. And the instructions to that human were just have a normal conversation, say whatever you want to say. The computer, on the other hand, has been instructed to deceive you. The computer's job is to pretend to be a human and do so in a very convincing way, such that you can't you, the judge sitting in the chair, can't tell the difference between the human and the computer. And if a machine can reliably pass this test, then for a number of reasons, we'll just leave them philosophical at the moment, but that is the only good measure we have of does it bear the property of intelligence? Lacking any other good definition of intelligence, this is the best one anyone's come up with. And as of today, if you test this in good faith, well, technically, you can't just test it going to ChatGPT. This has to be a double-blind experiment. You have to have many humans try this in, many pairings of a human and computer, and then look at averages. On average, does the computer fool the human? So they were doing tests of this for a while. I don't know if it's still going on. They had this thing called the Loebner Prize. And at the end, they asked the human to rate each participant, rate the computer participant and the human participant, or A and B as they knew at the time, on a scale of 1 to 10. How likely do you think that that chat person you were chatting with is a human or a computer? 1 being almost certainly a computer, or being human. Sorry, yeah. 1 being almost certainly a computer, 10 being a human. The average human got only like an 8.5 in their rating, not a 10 out of 10. And at the time, computers were getting like a 1.4. It was very obvious many years ago when you were talking to a machine. They would get into, patterns and cycles, change the subject, not be able to answer direct questions. All of that has changed pretty well. You can talk to ChatGPT and get surprisingly intelligent answers. However, in a good faith test, you will also be able to tell that they're computer answers. And when I say good faith, you go into it not just say, what'd you have for lunch today, and simple things that, of course, ChatGPT can answer, but use your intellect to test it, to say, what might a computer not be able to say? Describe a sunset to me or your happiest childhood experience, and ask follow-up questions and things like that. And under those settings, the current state of AGI doesn't pass that test. Now, what caused the leap forward? Obviously, I talked about GPUs, big data, and algorithms. But how do we make the algorithms do what they do? Just having a lot of computing power doesn't solve the problem. We have to make the computers do something. So Here's the four steps that I describe of how we solve AI or how we build it. First, we define a very particular math problem, and I'll talk more about that. Then we use machine learning techniques, just math, to solve that problem. It's a hard problem, so we need potentially hundreds of compute years. And what do I mean by hundreds of compute years? It hasn't been hundreds of years since we started doing this. Well, it's massively parallel. So if you had 100 computers running for 1 year, you would get 100 compute years. If you had what it would be 365,000 computers run for a day, you'd get the same response a lot faster. And then out of that solving of that math problem, the answer is something we call a model. And it is something like ChatGPT. And you can use that to inference new ideas, be that get text, get images, solve problems. It's a sort of a general purpose computing system. So let's talk more about that particular math problem. What did we actually ask a computer to do that spit out ChatGPT? Well, I'm going to give you one good example that is visual and helpful. This isn't how language models work. This is more how AI generated images work. But here we have on the left a real photo of a cat. And then moving to the right in the follow-up three images, I've added, or the creator of this image added more and more what we call noise. It's kind of like the static you would see on a TV that had no channel back when TVs did that. On the far right, the image of the cat is completely lost. This is almost as though you went through every pixel in the image and changed its value to a random number. And in fact, if you create a random image, it looks like the one on the right. There's really no information content left about the cat. But let's look at the second image, where if I just showed you this one in a vacuum, I'm sure everyone would say, oh, that's a blurry cat. You can tell it's a cat even though I've distorted the image. And maybe if some of you are really good at Photoshop, you could take that distorted image and go clean it up and make it look something like the original. So that sort of undoing process is what we call diffusion. So forget all four of the images and first focus on the first two. So take the blurry one and say the goal is to turn the blurry one into the clear one. Can you denoise this image? Now you probably can't get it back perfectly because some information is lost, but you can make it look more like a higher quality image of a cat, probably close to identical to this cat in a way that the owner would agree, yes, that is an enhanced image of my cat. So we know we can go from the second image back to the first with a little bit of loss. And imagine training a computer to do that. And once the computer gets good at it, try maybe giving it the third image and saying, here's a really blurry image of a cat, but restore it to being a cat. And then let's take that. Once it gets good at that, you have an algorithm that, denoises an image. You can take it a step further, give it the noisiest image possible. Here is just a random image. There's nothing in it. And you insist it's a cat. And then you take the output and you run it back through again and say, it still needs to be more like a cat. And through maybe hundreds of iterations of that, taking the output, feeding it back to the input and saying, clean it up more, from the noise, the random data can emerge a brand new cat who never existed. So if you go to sites like Midjourney or any of these AI art things and you say, I want a picture of a ghost eating a Whopper, and that's never existed before, but moments later you have a photorealistic image of a ghost eating a Whopper, that's through this process of diffusion. We started from good images, we added noise, and we taught the computer how to remove the noise. And then we just gave it pure noise and asked it to remove all of it. Now, in terms of text, we do a similar thing. The basic core problem, the math problem we give to AI and ask it to solve, is called next word prediction. And it was trained by basically taking any text, maybe this first sentence I have here, every morning she goes for a blank in the park. And I could ask everyone in the group to fill this in, and you'd probably have some common answers. Maybe she goes for a walk in the park or a jog, or she goes for a yoga session in the park. She probably doesn't go for an arraignment in the park, or doesn't go for, axe throwing in the park. These are not park activities. They don't fit with the context you have there. So if you hide the word and you ask a computer to predict what word can go in that blank, it learns to predict the context. So maybe next sentence, in the morning, I like to drink blank. Maybe some of you are thinking coffee or tea or a Diet Coke. Hopefully, nobody's thinking vodka. But through looking at lots of text, you will find so many instances of stories or blog posts or wherever where in the morning people are drinking coffee. So the computer learns to predict likely words that can fill in a missing place. So, in this sense, you're not giving it a goal. You're just saying, well, not a traditional goal, like you have to find the exact word. You're giving it an unsupervised problem in which you say, I'm just going to hide one word, and you look at tons and tons of text. You look at the whole of the Library of Congress and all of this kind of thing. And based on the statistical information you can build up about all of that text, what are common words that could fit in these blanks? And while there's no right or wrong answer, some answers are righter than others. And the machine can learn to fill in the blank essentially. That same idea, just like we talked about scaling up diffusion, we scale up the predict the missing word problem. And that's how you get large language models. So there's a sub problem there. Maybe some of you are thinking, okay, you're talking about text and words. How do you convert a word or phrase into a number? Machines work on numbers, not on text. Well, there's a few tricks for that. One solution would be you could open a dictionary, start at the first entry and label that one, the next word two, and so on and so forth, kind of like my list here, where abacus ends up being the 10th word in my imaginary dictionary. This is not a good strategy. This is just an example of one way you can convert every word into a number. In this case, that number doesn't tell you anything. Well, it tells you the order a little bit. It tells you which number is, comes sooner in the dictionary, but that's not super helpful. We would like for those words, those numbers, to have a meaning. In the same way, zip codes kind of have a meaning. I bet, a lot of you are three something. I don't know the Florida zip codes, but I know geographically you guys must be threes, just as I'm an eight over here in Las Vegas, Nevada. And as soon as you hear a zip code, that first digit tells you a geographic proximity. I don't know where you live, but I have a better guess than I did before I knew the first digit of your zip code. And in fact, as I get more digits of your zip code, I can keep zooming in. And with just 5 digits, I can get down to pretty small areas in the country. Some zip codes are pretty big, but some are small. And either way, every zip code is a tiny fraction of the country. So with just 5 digits, we can get to information. We want to find a way to convert words into numbers that has meaning associated with it, the same way zip codes have meaning. And that's done through a process called an embedding. Same idea as the guess the hidden word problem, but here's the more mathy version of it, and a history going back a little over a decade of some of the advancements that all use more or less this technique. And what it is you have some input layer. So this is all of the words you're going to pump in, like maybe a word can be assigned to a node, and then a hidden layer where there are less nodes here from which you want to faithfully reproduce the output. So it's kind of like a memory game. It's like saying, I'm going to, you have to go pick up a bunch of groceries, but you're only able to write down 3 things. So instead of writing down ham, cheese, mayo, lettuce, you would write down ham sandwich. And then you have to pick up all the ingredients for the ham sandwich. That's like a form of compression. You figure out a way to represent data with fewer bits of information. And that's through this embedding process. We find an embedding space where text goes in, it becomes encoded into a number, and then there's a decoder that can take that number back to the text and do so faithfully. So it's not going to make too many errors. If you put in hat, you should get hat back out. But maybe you'll get cap back out sometimes because those are similar words. Here is a visualization of an embedding. These embeddings are done in this is 2-dimensional space, right? We have X and Y. No third dimension in my chart. This data actually lives in like 100-dimensional space. Like one of the ones I work with, there's 739 dimensions, I believe. So not easy to visualize. But if we use other math techniques and we cram that number down into 2-dimensional space so we can look at it, you get this result. And notice that there's some similarities here. Teaspoon, teaspoonful, cup, cups, teaspoonfuls. All those words which are similar wind up in a similar place. Onions over here by its lonesome self for some reason. But in the upper left, notice pepper, salt, mix are all close together. Flour is near it. And as you look through this, you'll start to see that there's kind of a meaning to it, a context. Words that are similar are showing up in similar places. That's through the compression process. That's what the embedding is. Now, some further examples of that. Going back to 2013, this is when I knew we were really onto something, when Word2Vec came out over a decade ago. You might have seen some headlines way back when this first example made the news. So remember, we can take a word and convert it to a number. Okay, but what good is that number? Well, it's useful if it has some context. And one of the most interesting ones was take these four words, king, queen, man, and woman, and then convert them into numbers. Now let's do some basic math on that. Take the number for king, subtract the number for queen, and then add the, sorry, let me say that again. Take the term for king, the number for king, subtract man from it, the number for man, add the number for woman, and the number you'll get back is very, very close to the number that represents the word queen. So you have this sort of semantic emerging layer. And in the same way, verb tenses are understood by the machine. The relationships of capitals to their country show up in this embedding space by asking it to spend hundreds of compute days sometimes figuring out how to guess the next word or put words into a meaningful space. It does so in a way that assigns words that are similar with similar meanings, as we saw here, but also with relationships. So it truly has some notion of understanding going on through this process. Maybe not as sophisticated as human understanding, or maybe equivalently uh, good to human understanding if we scale that up. Kind of an open question. The main algorithm that I won't go too deep into because this is a somewhat technical thing, and I'm certainly not going to explain that chart for you unless anybody really wants that. I'd be happy to go through it, but just to give you a sense of it's a little more complex than I've hand waved over. But basically, the transformers are key algorithmic insight. It's a very clever design. It's easy to train it, and it has a notion called the attention mechanism. And what that does is looking at a sentence, it can kind of pick up on what words are important and how do they relate to each other. So in like this sentence, the FBI is chasing a criminal on the run. If you say who's on the run, well, you know it's the criminal, it's not the FBI. Who's doing the chasing? The FBI is doing the chasing. Who's chased? The criminal is being chased. And the attention mechanism allows you to kind of look at one word like run and understand how it associates and get the computer to understand what words that word relates to. So it can be like if you have a pronoun, who the word he, who does he refer to? We've remembered that from text clues and things like that. The computer doesn't have the same approach, so it uses the attention mechanism to figure out, all right, for my current word, what are the related previous words? And that's part of the magic process of it doing next word prediction. So all of this is mathematical. There are some key tools we have. One is gradient descent, which is just the idea of like sledding down a mountain. If you think of this colorful thing as a mountain and you want to get to the lowest point, aim your skis down and you'll get there. That's a mathematical technique called gradient descent that we can use to find, maximums and minimums and things. Those embeddings are a big key to it. When you ask the computer to compress the text in a way that retains information, puts it into a numeric space that's informative, the transformer that gives us the attention mechanism, and that deep learning technique I showed earlier with the circles and the weights, finding the optimal weights, all that's just math, but scaled up, doing massive amounts of it. And coming out the other end, we get a useful model that understands things about language. So that training is quite expensive. I mentioned earlier I couldn't really train my own model. That's because I lack $63 million. Or, well, I lack $62.99 million or something along those lines. But big companies are able to do this. They get hundreds or thousands, maybe tens of thousands of computers all networked together, all solving that same problem. And there seems to be no limit to this so far. We went from ChatGPT 3 to 4. We had an order of magnitude growth in cost, and that cost paid off. ChatGPT 4 is significantly better than 3, just as 5 is predicted to be better than 4. Now, we might hit a ceiling with that, but so far, there hasn't really been a ceiling. The more we pour into it, the more money, essentially, at this point, the more energy, the more training time, the more data, the smarter these systems seem to get. Just to give you some reference, here are some common data sets. All of Wikipedia has about 10 billion what we call tokens. You can think of that as a word, or it's actually not a word. It's, the components of a word, kind of like syllables, but more or less words. There are a couple other big corpuses, 23 billion tokens in books two, which is just a collection of books from across lots of years. And these are some of the training data sets that are available that go into how we let the machine learn how to understand language. So, what's the cause of the leap forward? How do we solve AI or build a system that has AI? You give it a hard math problem. In this case, some clever ones. We have the diffusion technique of take the noise out of the image, which leads to good image generation. And we have the predict the missing word, which leads to language understanding. So we just use those mathematical techniques, but scaled up massively. Hundreds of compute years these run for. And at the end of that, you can take the resulting model and do interesting things with it. Now, what are the gaps between today's AI and artificial general intelligence? Obviously, it's that today's AI does not pass the Turing test. But there are some other key reasons that they're different from AGI. Maybe these are the missing things preventing it from passing the Turing test. First, it has no long-term memory. Now, you can have a conversation with ChatGPT and it will refer to earlier things in the discussion. It'll remember certain things, but it has a context window. If you talk to it long enough, the earliest things you told it will fall out of the memory. Now, we can keep making the memory bigger, but that doesn't seem to be the perfect solution. What's actually kind of amazing about humans is not our good memory, but our ability to forget. We forget tons of information and we retain only the useful information. And that is something that's not clear how to do that long term on an AI currently. Current AI also is limited in planning. In fact, language models don't really have planning. They're starting to try and add things called chain of thought, where you plan out certain steps and then you execute steps one by one. But it's not designed for that exactly. Now, there are mathematical approaches. This is actually what I worked on in grad school for how you do planning. But those are techniques that haven't necessarily solved the whole problem yet. Maybe they will. But as of today, AI is not very good at long-term planning in the way we are. It's not good at planning in general. It doesn't have the long-term memory. Three, it's not autonomous. While I guess we could, set up a basic little robot, they exist today, and we could put a language model in it or some of the modern AI tech in it, it's going to be limited mechanically in what it can do. But it's also not clear that autonomy is going to give it an advantage. Although maybe we have one, right? We go out into the world, we have human experiences, those inform us, make us who we are. AI just has its massive training session once, and it doesn't relearn really the way we do. Fourth, it's very energy inefficient. I don't know exactly what it costs to have a child, but I'm sure it's not $63 million. And children eventually become intelligent and more intelligent than current machines. You got to give them calories and a few other things, but the total cost is a lot less than $63 million. So our approach to training intelligence in a computer, something's off or very inefficient when compared to humans. Maybe we'll figure out ways around that, but that's a current state of the art thing. Fifth and sixth are my own ideas. The first four are quite popular. You'll see a lot of people in the AI community popularizing those limits. Five and six, not that there's a debate per se, but they're not often highlighted. The fifth item, what I call is the oversimplified loss function or utility function. So if you want to build a chess playing system, the goal is to win the game of chess. And that's pretty clear. You won or you lost. And even along the way, they have board evaluation functions that can look at, the pieces you have and the positions you're in and give you a score of how likely you are to win that game. And that works great for chess, but there's no real world score function, like how good are you doing at life? I guess you could look at somebody's bank account, but sad world if that's the measure of a person. So when we have convenient loss functions like we do in games where it's easy to describe the goodness of the machine's performance, then it's easy to train them. And we have goodness in terms of like, how likely did the words you pick fit the sentence, but or how well did you restore an image that was distorted before it was given to you? Those are things that can be measured, but they're very crude in a certain mathematical sense, and that could be a limit. And then six, they seem to lack common sense reasoning. And actually, that's a popular one that you will hear a lot of people say. I'm less convinced it's a big barrier because I think a machine can probably develop common sense reasoning, especially if you give it the right prompts and tell it to focus on common sense. But as of today, it's certainly not the strong suit in AI, and you'll hear that criticism quite a bit. So these are some of the barriers between where we are today and how we would get an artificially generally intelligent system. All right, so let's do a few more terms. AI, as I've said earlier, is kind of really a buzzword at this point. Everybody says anything's AI anymore. That's why I like the term artificial general intelligence, a thinking machine that can adapt to new problems without being reconfigured or retrained. Most specifically, that it can pass the Turing test, that it can convince a human in a double blind test that it is a human being, that you can't tell the difference between a person and a thinking machine. And then there's another idea I haven't talked about yet, which is the artificial super intelligence, where not only does it pass the Turing test, but it exceeds human intelligence in novel and unambiguous ways. Maybe it's the best at every profession that's ever been. It's smarter than the smartest person, more clever than the most clever person, and we could be like children to it in some way. Is that even possible? I think that's open for debate. There's a good debate in this book called Uncontrolled. I interviewed Darren on my podcast. He also does his own podcast called, oh boy, what is it? The Reality Check, which is quite good and covers these topics a lot. So the idea would be, okay, a super intelligence. Well, what if it got loose on the stock market? Or what if it was shouldn't it make the smartest trades and then have all the money? This is perhaps a threat. Certainly, there are some threats related to where AI can be used. I myself am less worried about an artificial superintelligence than I am a human intelligence using AI for nefarious things like, I don't know, biotech terrorism. Could you engineer a virus somehow with CRISPR and AlphaFold and all these technologies that it targets a certain type of person or things along those lines? That's all not really science fiction anymore. Those are things that could be done. Could at super scales an artificial super intelligent put fake news everywhere, right? 10,000 fake news stories a day and cause social unrest, cause the economy to collapse somehow? These are possible threats. I think many of them are more science fiction than possibilities, but there is definitely a looming threat of a superintelligence coming out of it. No guarantee this can happen, but worthwhile of debate. And I would point out that although human beings have invented nuclear bombs several centuries ago, we also haven't dropped any for centuries ago, decades ago. We haven't dropped any for quite some time. So maybe this technology bears a threat, and maybe we will use it responsibly. Although nuclear bombs, they are dropped. They are not sentient in the way that an artificial superintelligence would be. So it's not quite an apples to apples comparison, but still something worth considering as you worry about how late to stay up at night thinking about a superintelligence. Um, so some of my key takeaways. Artificial general intelligence is in no way considered impossible. I didn't even really harp on that because that's not much of a debate anymore. It was in the 50s when Alan Turing started writing about this. People would think, oh, a computer will never be intelligent because it doesn't have a soul or, any number of other things it can't do. It can't be smarter than the person that programmed it. Well, that's certainly false, and we know that today. Um, there's no real reason to think a machine can't be intelligent in the way we are. We seem to be on the right path. I don't think we're building a staircase to the moon, but we're also not there yet. We don't have AGI. The Turing test has not been passed. Maybe it will in the next decade. I don't know. That would be very exciting, but we're not there yet. We do think we're on the right path. We know some of the gaps, but it's all still research. Regardless of that, even if there are no more advancements, this is already a powerful technology that can be deployed, and you'll start to see AI coming up in tons of new places as we solve what I call the last mile problem. How do we take that language model that's so good at understanding text and plug it in everywhere? use it in your email to write auto responses or do spam filtering, all those sorts of things. That's all coming very quickly. A thinking machine, there's a debate about when that's coming. And last but not least, this superintelligence idea, I think, is something to be skeptical of, but also considerate of. We're building an advanced tool, and we're going to expect society to use that tool appropriately. So, what's happened? We had the hardware jump with GPUs. We have all this data on the internet, all these algorithms, and the ability to scale them. So, that's really the reasons about why AI has happened right now. We have, things coming forward. You're going to see a lot more with video in the next couple of years, personalization. AI is certainly going to keep moving, but it's unclear how far we are away from artificial general intelligence, which is the most exciting thing for me to watch for. So I hope I brought you a few insights about where we are with AI, and I would love to take any questions you guys have about it as well.
Okay, we're going to take some questions from the floor. Thank you. Okay. And before we do, I have one more, two announcements, and then we're going to go into questions on the floor. And if anybody is on online. Okay. One thing is, of course, we didn't yet acknowledge our programming committee, if they could stand or wave, because they are the ones who design every single program that takes place every single year. And this is going to be our 48th year of programs. That's a lot of topics. Okay. And for those of you who would like to join any of us for lunch at the diner behind the clubhouse, just go on over. I'll be last, but you don't need me to sit down. Anyway, you were invited to come, and it would be nice to see you. So, Kyle, we have questions from the audience. Steve is going to pass around a mic, so you don't have to get up, all right? And once again, Kyle, thank you.
Start with you, maybe keep it short this time.
Keep it short.
Very difficult to keep it short on a topic as in-depth such as this. Harold is my name. And okay, I get frustrated when I attempt to communicate with a computer on a chat line that responds only with non-applicable options, such as like none of the options say none of the above. They give me this a limited number of solutions, and nothing of them is even close to what I want. I mean, I attempt to say, speak to an agent. No, they just ignore me on that. That's the biggest problem I've ever had when trying to communicate with the computer only with a limited number of options. What can be done about that? Can AI literally, modify the responses to allow us to say, you have to do better?
Yeah, we're in a time now where that's certainly possible. I think companies, especially big profitable companies that still have menu systems like that, should almost be ashamed that they haven't deployed the technology to improve their customers' lives, because that's an old school way of doing it. You three options, you press one, two, or three, and that's it, and it can't understand you. I get your experience and frustration. That is because the line as it's been built, whoever the provider is, whoever engineered it, they used older technology. If they would involve more AI in those processes, they'd better be able to understand your needs. But even then, it has to be designed well. I think the prompt should say, not only, help this customer, here's things I know about it in giving, you your responses, but the prompt should also be trying to detect, are you frustrated? Is it failing? And if so, escalate you to an actual human being who can then probably be equally unhelpful to you, but at least you're talking to somebody. It's a matter of engineering that just needs to be built correctly.
I have another question that should be quite simple. Will the results for a problem be radically different in the AI when the problem, a text, is translated into a different language, like English to French, going through all the iterations? Because you can take a word, but without the context, it can have radical different meanings in different languages.
This is true. So I didn't touch on translation, but I'm glad you brought it up, because it is widely accepted today that the best translation algorithms are better than human translators. They've gotten that good. And in fact, language, there was an interesting study when they started to look at these translation systems saying, well, how do they work? When we go under the hood, what's happening? It seems to be the case that the machine first translates into like a universal language. It just has its representation, that embedding space I was describing, and then translates out to whatever language you want. So it's understanding language in this very high level, big picture sense. There are subtleties of language, as you point out, that it might not catch, but that's largely due to it not being not having enough training data on those specific cases. If you give it more, it wouldn't surprise me to learn it struggles with Native American languages because I don't believe there's huge corpora of text examples the way there is for English and French. So probably it'd be really bad at translating to Native American languages. But what would need to happen then is just more examples of that text for it to get better.
Okay, thank you. My last question is probably going to be the most difficult to answer. At the beginning of your lecture, you gave an example of missing words to fill in, like we're going for a something in the park, like a walk in the park. And you say, they just have to have a list. They'll be able to fill it in by searching. I think, how does it do that filling in? How does it have the list that's applicable? That's probably a 3-week or a month or several month long course just to answer that properly. But can you give me some idea? How do you go from a missing word to what are you going to fill in with?
So think about a very rote mechanical process I'm going to give you, the most boring job in the world. And you're not going to solve it with your intuition, but instead you're going to go through every book in the library and find when a similar sentence appears, and then see how that book filled in the blank. And then you'll come back to me with, probably 16 examples that all have it filled in one way or the other. You could also take every word in the English language and assign a probability. Could this one fit? Try each of them. And while that would be mind-numbing for a human being to do, a computer that does billions of operations per second can accomplish that. And through doing it at a large scale, it learns the right probability distribution of what fits in the blank, simply by example.
Thank you.
Want to go next?
Was I short enough?
Yeah, thank you, Jim.
Okay, thank you, Kyle, for your presentation. I'm a retired engineer. When I started school, before there were even the little handheld calculators. Somehow we got our jobs done. But okay. One thing that doesn't get discussed very much with all these massive, powerful computing machines is the amount of massive electricity that's needed. All these gigantic new power plants being built, taking up land, really damaging the environment with more and more and more power plants being built with disregard to people in these communities. And what do you see as the approach of these huge multi-gazillion-dollar companies that keep doing this without thinking about what the impact is? So that's one of my big issues, okay? Thank you.
Yeah, I think it's a very valid concern. We are seeing, everything you said is true. Huge demand for energy. 63, those numbers I quoted and what it cost to train weren't just about the computers. It's mostly about the cost of the energy to do that. So on one hand, I expect the approaches to get more energy efficient in time because it doesn't make sense that the human brain is intelligent on such a low cost in terms of like energy. Our calories are insignificant compared to the tons and tons of energy computers require to do this sort of thing. So should there be a responsibility on the companies? I'm not sure exactly. I would first wag my finger at cryptocurrencies and the blockchain, which uses enormous amounts of energy for probably less gain and less good, whereas AI does some very defensibly good things. Protein folding is effectively solved because of AI. That's going to allow huge advancements in medical science. We're going to see a lot of medical advancements that are going to make people's lives better and longer and healthier that are going to come directly from AI. So where's the trade-off? How do you know how much power is worth it? That's for society to decide in certain ways. But this is a major concern. These are energy hungry systems. But it seems to be that they maybe justify themselves, or at least to a certain degree they do. So that's the debate that has to go on.
Okay, thank you. I hope you're right.
Mhm. Speaking this way.
Thank you for your presentation. I'd like to know if it's readily available on a computer.
I think this was recorded, so if the organizers will share it, that's good. Or I can also share the link to my slides.
Questions. As we go forward, is man's mind as we know it today going to become obsolete?
Very interesting.
Secondly, what's going to distinguish an IQ of 120 to an IQ of 220 if we can all go into AI and get the same answer?
That's a very interesting question as well. Yeah.
Okay, thirdly, speaking of medicine, if we would have asked about a computerized heart 100 years ago, they would look at you like you were on pot or something. Same question about a computerized pancreas. I'd like to know your comments on that.
So I'll go in reverse order then. I don't know exactly what a computerized pancreas is, but if my pancreas is failing and they offer me a computerized one, I'm going to want it. So the ability for technology to supplement the body or help in cases of disease or organ transplant, a little distant from AI, but I think maybe AI could help us get closer to those points. And I think that's a big benefit. Wherever medicine can be advanced, I think that's a good thing, as long as it's not done, like Tuskegee was not a good thing, clearly, and stuff like that. But, ethical medicine is always good, and AI can help advance that. I think your second question about IQ and what will it matter when we can all get the same answer, very interesting. I don't know that I have a good answer for you. I think it's philosophical in a certain way. We're seeing it now, right? Like it used to be you could go into a bar and there'd be a guy just making stuff up. Now I pull out my phone, I Google what he says, and I say, "Hey man, you're full of BS." I can fact check pretty well, although I can also find bad information on the internet. So I think intelligence will evolve. Where it used to be maybe if you could memorize a lot, you were considered very intelligent. The value of memorization is going to decline, I think, in some degree. Maybe that's for the good or for the bad. But computers are not clever in the way humans are clever. And I think our cleverness is what's going to keep us separate, keep us from becoming obsolete in certain ways. The machines we have today, they don't have a motivation, they don't fall in love, they don't have goals. All of the very human qualities we have will stick around. And the way in which we use technology to interact with the world is certainly going to change. But that's nothing new, right? 100 years ago, most people worked in agriculture. Today, and I'm grateful that I don't have to, most people don't. We have what I hope you'd find are easier and better paying jobs. And I don't know exactly what the future is going to look like in that way, but I don't see myself becoming obsolete. I think it's more of a stand on the shoulders of giants thing.
Hypothetical. If 10 million people went on a computer Sunday night to say, give me 5 stocks to buy Monday morning, what's the implication of that?
Well, I think much in the way financial advisors are going to give you, questionable stock picks. I think the AI can probably give you questionable stock picks as well. The market is a complex system and dynamic system and largely unpredictable. If it was predictable, people would figure out how to predict it and they'd make all the money. In fact, that's what hedge funds are, right? They figure out something clever and they close the gap of the margin until there's no more profit to be made. So, my personal approach to investing is buying index funds that rarely can anyone beat the market. And I don't think an AI is going to change that for us.
Society today has all kinds of emotional problems. What role could AI play in helping that situation?
Could you give an example of an emotional problem?
It could be drug use.
Sorry, could you put the mic?
Drug use, irrational thinking, hallucinations, some of it DNA driven, possibly, other responding. Let's take the Trump problem, how people deal with it, and the emotional trauma that our society experienced, where families were pulled apart, relationships were pulled apart. How could AI play a role in something like that?
So I think it's in how we apply it. If you take an example of something like, let's say, schizophrenia, it is possible that AI could be scanning your emails and your text messages. Obviously, it needs to have permission to do all that, but it could detect that a person is having an issue like schizophrenia. Or I know there was a statistical analysis of Agatha Christie books, and you can see a cognitive decline in something about the way the last novel she wrote was written. That happened after the fact, but if a computer could be more closely monitoring people, it could identify, early precursors to that, maybe people who have psychological issues. It could alert their therapist or psychologist or treatment person, hey, they're having an episode. When it comes to something like drug use, I don't know that AI can talk a person out of taking drugs. Maybe let's give that a shot. I think more so it would be understanding like the pathways that lead to drug addiction and how it can help medical science come up with better treatments and things like that. There's also talk about AI as a therapist. If you can't afford a human therapist, I think it's a great alternative, especially when the other alternative is nothing. But therapy is something that people are trained to do. And I'm not convinced a computer can do that as good as a person, but some opportunities there. And I think overall, in being a tool for people trying to understand information. So let's talk about like fake news or misinformation. AI can very quickly help you determine, is something fake news? Does the, here's a statement that a politician made. Ask the machine to say, does this seem credible? Can you find sources that prove or disprove this statement? And it can speed up that fact checking process. So maybe we can get to a more intellectual discourse by using AI for fact checking.
You mentioned fake news and the AI being able to regulate it, but in the meantime, it hasn't regulated it. And we had a lot of fake news going around during this last election that probably influenced the outcome of it. What controls do you think people could have over some of the negative aspects of AI?
Well, it's tough to say because I don't like draconian ideas. For example, if there was a law that said every news story has to run through this AI and it's going to say yes or no if that's fit for print. I mean, if you own a newspaper and you choose to operate your newspaper that way, that's fine. But I wouldn't want a law that says every article has to pass some test because I think that would be very easy to turn into a bad thing that's controlled by someone for nefarious purposes. But I think as people start to get better at using AI, it'll be a tool. I often reminded of the Terminator franchise of movies. Remember in the first one, Arnold Schwarzenegger is sent back to kill John Connor. And in the second movie, John Connor in the future reprogrammed the Terminator to be his protector and sent him back. So the AI fought the AI. And I think that's what needs to happen here. In the same way, I can use AI for bad purposes, generating fake news, fake images, things like that. Someone else can use an AI to detect the fake news, the bad images, and circulate it. So it's a new set of problems. I don't think AI can immediately solve it, but the better we use it as a tool, I think the smarter we can be as a society. But that depends on everyone deciding to do that. I don't know that someone who isn't open to facts or new information is going to be convinced in a different way because of AI.
I have another question.
Yeah. I wasn't referring to AI solving it. I was referring to human beings placing some controls over AI, because sometimes it feels like all whatever happens on the internet is okay. If you did it in person, it's no good. There are controls, things are illegal. But if it's on the computer, there's no control over it whatsoever. And what control do you think human beings are going to have over AI once it becomes so prevalent?
Well, we can always pull the plug. That's part of it. Now, it's maybe not as simple as that because AI can be distributed, and if a bad actor is using AI for nefarious purposes, we can't unplug their AI. Um, I don't know that we need special controls on AI above and beyond current approaches to law. So it's there's some reason I can't send you a threatening letter, like threatening your life. I don't know exactly what law I'm breaking, but I'm sure I would be breaking a law. What if we asked the AI to write the threatening letter? I still sent it. I'm still the criminal here. AI is the tool I'm using. It's also a technology that would be hard to restrict, in the same way electricity is hard to restrict. You can't tell someone how they get to use electricity in their home. I mean, certain things like if you can't use it to make methamphetamines, I guess, stuff like that. But if I want to power my TV or my video game or my stove, those are my choices. Um, so it would be very difficult to put any restrictions on AI. I think the most we could do is restrict the companies that build the large models. And there's some steps in that direction. There was a law passed saying that what I think is probably a very weak law, but a law that said if you're building models above a certain size, you have to be in communication with the government about what it's about. Now, what does that mean? Is that effective? Is that useful? I don't know, but that is the step that's been taken. Beyond that, I'm not really clear on what restrictions we can take. I think it's more of a societal choice. Like if we want to all agree that there shouldn't be pornography, we could eliminate that. We could use technology to do it if that was society's choice.
Yeah, thank you, Kyle. That was an interesting presentation. I actually have a question, like moving away from necessarily your presentation, because someone handed out this. Are we going to be talking about that? Yeah. So this is what I want to share, not having to do with AI. I use AI every day, all day, as
Cool.
part of my job. I still work fully full-time. Thank God, I still know a little bit more than it. So these companies send me all this written data that AI wrote now, which I used to write completely. And now my job is just to review it for accuracy. And it's still making lots of mistakes, but it's a lot better than it was 5 years ago. So I imagine soon they won't need me to review it, and that'll be my problem. But what I really wanted to ask about is what was handed out, and you guys all this. This is something that happened to me yesterday. And I'm just wondering if anyone has information about what to do. I have a grandchild who's disabled. I have a caregiver for him who is from El Salvador, and he's been my caregiver since 2019. Yesterday on Long Island, in Brentwood, Long Island, I set up a blocked place where every car that drove through, they stopped each person and looked in. And if you looked like my caregiver, who is from El Salvador, he's been in this country 30 years, they took him out of the car. They took him to the police station. They kept him for 6 hours. They did a strip search on him and kept him there until he could prove, which was very hard to do when you're in that he hasn't committed a crime. They could not find a traffic ticket on this guy. And yet they kept him there for 6 hours and then summarily threw him out without his clothes. He had to put his clothes on, like in the waiting room. Is this America? And what can I do to help him? Who can I report this to or do anything to? I mean, this isn't, it's not that long ago since my Jewish relatives that happened to, or anybody else. It's horrendous. That's all I wanted to say. If anyone has a suggestion, after we break, you can let me know. What can I do to help my worker? So it's very scary. It's a lot worse than I think we realize here in our little Century Village place.
Is there any question from Anybody on Zoom before we start over here? 2 people? None. Okay. You want to go first?
Yeah. Okay. Thank you very much for the great presentation. It was very interesting. This paper everybody have, and probably that's why you ask about this. This is some ideas about how to correct U.S. immigration policy, and those ideas were created by AI. And this AI is DeepSeek, which is local model I have on my computer. What that mean? That mean, oh, here's, you can also look it over there. This is very intelligent text, very logical and makes sense. And I only ask DeepSeek to first make the US immigration policy more in according to human rights. And second, make it bipartisan, so it will be realistic. And that's it. And the model came up with this. What I'm talking about this? Because probably many people using ChatGPT, which is a model you need to connect through internet. And then you basically connecting yourself to big company who have all control of about everything you talking about, getting all the data from it and profiting from it. So my question is about local models. The idea of local model is that you can download it to your own computer. It basically lives on your computer, and then all data you put into it are safe because you just talk in your computer. You can cut off the internet and still get very intelligent text about whatever you want to ask. And the idea of local models is maybe we need to give AI for free, like for our computers, so everybody have it, not just big companies or governments using this to make money or control people. So what's your idea about local model movement and all this stuff? Because that also have some dangers with it, I know that. So that's my question.
Yeah, I think we need a balance of these things. Local models are good in the sense like, you have no concern now. Is the government going to read what I asked it or go through these logs? You have a guarantee of privacy. In the same way, there's some alternative to Google. I'm forgetting the name of, but an anonymous search engine that a lot of people like, DuckDuckGo. So it's I'm glad, even though I don't use DuckDuckGo much, I'm glad it exists as an alternative to Google. It should. We should have, a variety of approaches. So having a local model is a good thing for numerous reasons. I think in your case, the privacy one, I think there are other advantages too, but it can be difficult to set up. It can require you to have a good computer at your disposal, and you have it once versus like when I use cloud AI in my business, I pay for it to run on their servers and I pay, like a penny or whatever for each use. So I like that for the simplicity of it. I don't have to maintain those computers, but I'm also not too concerned on the other side of it. Like, oh, is OpenAI going to use my text? If I use Grok, is Elon Musk going to read all my things? All that's possible, but there could also be like a DuckDuckGo for language models where it's end-to-end encrypted. And I hope we'll see things like that emerge and that we have a variety of tools available.
Thank you.
Hi, thank you so much for all of this. As a teacher for 40 plus years, I'm really concerned with critical thinking. And I'm wondering what AI and the use of AI, in your opinion, what impact it will have on critical thinking. Because the separation of a person with an IQ of 200 and a person with an IQ of 90 is not going to be clear with AI, but the ability to do some critical thinking and the encouragement of people to do critical thinking is one of my concerns when it comes to AI.
So I'm pretty optimistic about that. I actually think it can help with critical thinking because if you know how to use the language model, you can say, present it with a steel man argument. Tell me the best version of side A's point of view, and then tell me side B's point of view, and may even ask it to compare and contrast. So as a tool, just as like the example that was on the screen a little earlier, make a bipartisan solution that will appeal to everyone. That's a nice use of AI, and I think if we use it in the right way as a tool, it can be good for critical thinking. We've had those fears before, right? They thought that the pocket calculator was going to make everybody bad at math. It didn't. I mean, I'm sure my dad is much faster at long division than me, but I don't need long division very much. Um, Similarly, people thought Google was going to make us all dumb, that everything's just instantly there and available. But I feel like it scaled things up. You can learn faster, you can get to more information. And yes, that's more of a burden on a student to try and figure things out. But we've always needed to teach critical thinking skills. We should continue to teach them and apply them even specifically in the AI domain. I was talking to a teacher, a physical therapist teacher. She like teaches nurses recently, and she was worried about the use of AI in her classroom, thought that someone wrote their essay with AI, and I showed her some tools that'll try and predict, does it look like this is an AI essay? But more than that, we came up with a good use case for her students where they go through like a clinical diagnosis process. Tell me your symptoms, I'll ask you questions, and I got to give you a diagnosis. I said, well, why don't you have them chat with ChatGPT the same way, tell it some fake symptoms, and see if it can come up to the answer you have in your mind. And then, even better than that, see if you can trick it. Can you tell it good statements and give the wrong answer out of it in the way that a nurse would get the correct answer? Because now you've learned something about where the machine is limited and where it's making a flaw. So, as long as we don't think of it as this perfect source of information, same as anybody's cousin who has stories to tell, you got to fact check and verify everything. If we're good at that, the way we should be as critical thinkers, it can only be a good tool for us, really, is my opinion.
The training has to be there, though, in terms of skepticism, because that's part of being a critical thinker. And so it's still my concern. It's still a big worry for me. And my second question actually has to do with something in the room with respect to people being locked up and so on. So maybe that's something that we can just discuss in the room, because I have a story that's worse than yours. And it's from 40 years ago.
Anybody else? One more comment. Okay.
And I'm done. What we forget, it seems to me there are two elements. One is mental and the other one is physical.
You have to speak into.
One is mental and the other is physical. You would almost have to be walking around with electrodes over on your head, reflecting everything that you think 24/7. Now, physical, I can say I had breakfast this morning and I came to AI and I had a little Danish. I could record into something. How does this get recorded?
You mean our thoughts? How does the brain get recorded? Is that right? So I'm not sure that it can be. Like we have MRIs and things like that. But, well, let me just give you as an example. I don't believe there's ever going to be a machine that you wear while you're sleeping and your dreams are going to show up on a TV. That just seems like science fiction to me, based on what I know about the brain. It's a complex system that, our consciousness, all these things are emergent phenomenon. So it's not like there's a movie being played in our minds that can be recorded. It's a very complex system of electrical signals bouncing around. You'd have to really capture the whole brain to record it, and I think we're not close to that by current neuroscience technology. So I don't know what it would mean to record everything in the brain directly. Maybe everything you said, you could have a microphone on you all the time, but I think it'd be a challenge to make a useful recording of thoughts.
Thank you.
Just one last question regarding economics, which you really haven't referred to. Not the vast majority of our population is going to be able to learn and apply AI. And, there has been discussion about all these jobs are to get lost. And what are we going to train what kind of just more basic, simple jobs for people that's their ability to do. And if AI is going to keep taking away these jobs, that's going to be a big problem. Secondly, in regard to that, where there's been discussed about writers and people making music and all these things that AI can do. And people are going to be losing their abilities and their income from using creativity. So again, it's one thing for these gigantic corporations to keep pushing all this artificial intelligence out without really having any thought or concern for all these other aspects I'm bringing up. So maybe just your perspective, young man, because I can see you at least are more thoughtful.
So there is a concern I have about the economy, not so much that jobs are going to go away, because, well, first of all, jobs go away. That's natural, right? I don't know any out of work typewriter repair people. They all found new employment, new skills, transferable things. What does concern me is a big disruption. Like, I'm doing okay in my life financially. I could lose my job and, be off for a while, find another one, even without the safety net. There's unemployment, things like that. So as a society, we try and be protective, but I'm aware that for the majority of Americans, if they lose their job tomorrow, especially if they lose it to AI, they're going to be in trouble for a little bit. Same as lose your job for any reason, you'll be in trouble for a little bit. And I'm sensitive and sympathetic to that for sure. And AI can be disruptive, but I don't think any more than the cotton gin was disruptive or the electricity's been disruptive. Like I said, 100 years ago, most people worked in agriculture. Today, we don't. I think the jobs people will have 100 years from now haven't been invented yet. So there'll be disruption in the economy, but the economy will evolve. Now, specifically to creators, like you brought up, writers, things like that. Yeah, I think those people for the longest time thought that they were safer. Although maybe we can look at musicians where it used to be you made a lot of money as a recording artist selling CDs and albums and things like that. And then along came the internet, and now musicians don't make any money on recordings, really. They make their money through touring now, is the whole way that industry has shifted, or at least for a lot of those people. So I think we'll see things shift. People who used to be copyright editors or copywriters will now be copy approvers, and they'll use an AI, but be at the helm of it and things like that. So I am concerned about its disruption, but I also believe strongly in its productive power and ability to create new jobs as well as it eliminate someone's.
I want to ask you about black box problem. You know what is it?
For sure.
To make it more serious, because there are movements which say we need to stop AI or pause AI. People are protesting, people are blocking the entrance to OpenAI company. And why they do that? Because they scared of these black box things. The idea is that not only us who are not professionals, but even the professional scientists who build AI do not actually fully understand how they work, how they make interdecisions. And there are very serious people who say that. I will tell you. Andrei Karpatny, who is co-founder of AI and who is director of Tesla AI, said that we can measure how this works, but we don't really know how these billions of parameters collaborate to do it. Or Geoffrey Hinton, who is, who got Nobel Prize and Turing Award for AI. He said, we don't know how it exactly works. So the journalist asking, what do you mean we don't know how it works? It was designed by people. And then the answer of Hinton is, no, it wasn't. What we did, we designed the learning algorithm. That's a bit like designing the principle of evolution. But when that algorithm then interact with data, it produces complicated neural networks that are good at doing things. But we don't really understand exactly how they do these things. So this is very serious people saying very scary stuff, and I want to comment on this. What do you think?
Well, you pick two experts who have a lot of good things to say. Karpathy and Hinton are definitely luminaries of the field who know what they're talking about. I think it's a little. I'm not a big fan of the term black box because I don't think it's entirely accurate. So, if I ask, you want to ask the question, why did World War II happen? You don't want the answer from a physicist who's going to talk about superpositions of electrons, even though maybe fundamentally that's how the universe works. So I can tell you everything about a neural network if you want to stay the whole day, how the neurons assemble, how the learning algorithm works. I know every part of it mechanically, but it won't be satisfying to you. It'll be like saying World War II is protons and electrons moving around. Um, so we need other language to describe it. The other reason I don't like the term black box is because it's not entirely true. Black box implies there's no way to look inside. We can look inside at everything. It's just a very complex system that it isn't clear how it works immediately. However, there's a lot of work called AI interpretability going on, where, for example, in like computer vision, you can, we have these systems that can say, oh, that's a cat or that's a 57 Chevy. They somehow, the black box knows what's in the image. But if you build an auxiliary system that looks at those parameters, it's able to find how they're layered. So at the lowest layers, they're doing like edge detection. They'll know like, oh, there's, contrast between this point and this, the same way like you see my black headphones and the white background. The lowest layer neuron will draw a line right here and say, there's a contrast change. And then from edge detections, you can detect shapes. A square is 4 edges, a circle is something, lots of edges, a triangle is 3 edges. And a face is, a collection of shapes. And you have this hierarchical buildup of things. And that's what's taking place. That's what the learning algorithm does. And there are tools for investigating how did it get to this answer. But they're tools you kind of have to be a trained operator to use. So it is a black box in many senses, but it's also fully there in the machine and we can inspect it. So while I'm not ready for an AI judge in a courtroom, I think that's much too soon for something like that. At least an AI judge, we can review its source code, we can inspect every bit of the machine and ask any question we want. Versus a human judge, you can't really know their true intention, what's going on in their mind, or if they had, the wrong lunch and now they're upset because of that. We can't look inside the human brain as effectively as we can look inside the black box of AI. So the fact that we've built it and we can build more and more tools to inspect it, I think is sort of my response in general to the black box concern.
I'm going to give it back to Chippy now.
So Kyle, thank you. I have to go back and think about this for the next 3 days, but thank you very much. And
My pleasure.
thank you. And I think everybody else feels very similarly. So
I have
we'd
a
like to
question
thank you. You
from
have a-
Tom online.
Oh, okay, we have a question from someone online. Okay. Who is
Hi,
it?
I'd just like to know if anything has been done to program emotion into this AI, because I think emotion has a very important place in human thinking.
So, short answer, no. If you look in the literature, there's a lot written about emotions, but it's kind of like a toy academic thing. For example, like I remember when I was in grad school, there was another student working on a paper for game playing, and had a notion of like, oh, it could be injured and that would make it more risk averse, but it was very constructed. There isn't anything formally about making emotions in language models and things like that. If they appear to show them, like you could ask it to pretend to be sad and respond in sad ways, they seem capable of mimicking that. But truly, they have no dopamine system. They don't have any of the hardware we have, like emotions. So, no, not really. There's no emotion, but maybe we'll see emergent emotions. They don't have a pain system the way we have, and a lot of our emotions derive from that. But does love derive from our limbic, pain system and nervous system, or is that a higher order thing that emerges in intelligent beings. And if that's true, then maybe it'll emerge in an AI as well. But there's no serious effort to put emotion in them today that I'm aware of.
Okay, so we want to thank you very, very much and wish you a great nap.
Well, thank you. It was a pleasure.
Okay, and bravo.
Bye-bye then.
Well, you now have a lot of new friends in Florida if you want to get away for a few days.
Oh, glad to hear. We'll keep that in mind.
Okay, thanks a lot.
Thank you. Bye-bye.
All right, bye-bye. And we're finished. Okay,
Thank you,
thanks.
Carol. That was a really great presentation.
Thank you very much, and well, I want to thank our programming committee too for all the work they put into it. Everyone, I'm going to miss you over the next few months, but we'll see you in December. You have our Facebook page now. We have a website. You have my phone number. We have an email. I think we have more, but I'll let it go with that for the moment. And thank you all, and we'd like to see you very much in January. And if anything comes up, and if you have an idea for a speaker for next year, call me, because we're looking for 5 speakers right now. Okay? Thanks so much, and we'll see you then. Bye-bye.